Hi, AP Stats. I'm going to cover section 10.2 here in this video. What we're going to be looking at is two sample confidence intervals and two sample tests for means. So going through kind of these learning objectives, if we look at the sampling distribution first, the center, the shape, and the spread. The shape, three scenarios that we've seen before with the one sample, population's approximately normal, central limit theorem applies, or we're going to have to make a box plot, in this case, two box plots because we have independent random samples. The true center is going to be the difference between the parameters, and the variability is going to be adding up the variances. And we're going to have to estimate two standard deviations. We're going to use the sample standard deviation for each group divided by the respective sample size. All right, looking for the conditions. Your random condition, one of two things is going to happen. You're going to have independent random samples of whatever sample size 1 and sample size 2 are, or you're going to have an experiment, which means you're going to have random assignment 2. It could be 2 or more treatments, and you want to explicitly say those in context. 10% condition, we're going to have to check that twice if we have a random sample or independent random samples. If it's an experiment, you do not need to check the 10% condition. Just a reminder on that front. Normal and large sample, just mentioned above, you'll have to check the central limit theorem twice potentially, and you may have to do two box plots, which is a pain in the butt, but it's the reality of the situation. Maybe you have to do this once on your AP. Hypotheses. How this is going to look is we're going to assume there's no difference between the means, whether you write it like this or that they're equal. The alternative, 1 is bigger, 2 is bigger, or they're not equal. You're just going to have to define those parameters with direction, and I'll show you how to do that. Conditions, we just talked about those. Nothing new there. So the 4-step process is still in play. It's going to be pretty cool to kind of see this come to a head here as we finish up this unit. All right, so on page 2, we have the construction of a confidence interval comparing two means. So we are going to follow the same process that we have followed. I'm going to put the state step up here just because I want to make sure I have enough room. So I'm looking at the difference in the mean number of chocolate chips and Chips Ahoy and Great Value cookies. So UCA, true mean number of chocolate chips in Chips Ahoy cookies, and mu GV, true mean number of chocolate chips in Great Value, the generic brand cookies. Okay, so I do need to state a direction. How do I want to do the subtraction? Chips Ahoy minus Great Value or vice versa. It doesn't prompt me to one or the other. So I'm going to do Chips Ahoy minus Great Value. I'll assume the name brand has more chips in it than the Great Value. Okay. Plan. So I'm going to go through CVS, random condition. They randomly selected 10 bags of Chips Ahoy and 10 bags of Great Value, and then randomly selected one cookie from each bag. So here we have independent random samples of 10 and 10. You want to include both sample sizes. You want to make sure you explicitly say they're independent. This is not an experiment. There's no random assignment, so I didn't need to worry about that. For variability, the 10% condition, 10 is less than 10% of bags of Chips Ahoy, and 10 is less than 10% of bags of Great Value. Very reasonable, but there's at least 100 bags of each in the world. Shape. Okay, sample size is 10. 10 isn't big enough for the central limit theorem to apply. I don't know anything about the shape of the number of chocolate chips in these cookies, that distribution. So I'm going to have to create some box plots, which I'm realizing now I did not put on this page, which is so not exciting and actually frustrating. So that's interesting. Let me see what else. Okay. Oh, good. It's good. Maybe I did it on purpose. Sometimes I do. All right, so here's what's going to happen. We're going to have to create box plots for this data as I grab my calculator. So what I'm going to do is I'm going to go to stat edit. I'm going to clear out what I have in there, if anything, in list one, and I'm going to type in the cookies into list one, the number of chocolate chips for the Chips Ahoy. Then I'm going to do the same thing in list two. I'm going to clear that data out and type in the chocolate chips in the great value cookies. All right, at that point, now I am going to go to second y equals. I'm going to turn my plot on. I need 1 in list 1. Then I need to turn a second plot on. So I'm going to go over here to plot 2, turn this on. I'm going to select the box plot with outliers, L2. Then just make sure you don't have anything in y equals. You don't want any other graphs coming up. And then if I do zoom 9 is going to be zoom stat. I'll get my parallel box plots. Okay, so I'm looking for no strong skewness or outliers in either. I can see right now I don't have that, which is good. So here's what I'm going to do. I'm going to hit trace. It looks like the smallest minimum is 14 and the biggest max is 26. So I'm going to do this as simply as possible. So number of chocolate chips, we have in list 1 I put Chips Ahoy, and in list 2 I put great value. So it goes from 14 to 26. So if I just do this 10, 20, 30, you want to make this as simple as possible and quick and efficient. Okay, so I'm looking at the Chips Ahoy distribution. I got 16, 17, 18, 20, and 21. And then for the great value, 14, 17, 19 and a half, 22, and 26. Okay, I got labels. Now I'm going to need to state box plots show no strong skewness or outliers. So our sampling distribution is going to be approximately normal. So at this point, conditions met. We're going to do a 2 sample t-test. The degrees of freedom that we're going to use is the smaller of the sample sizes minus 1. So both sample sizes are 10. In this case, doesn't matter. So 10 minus 1 is 9. Okay, so that's the plan step. Do. I'm going to need some summary statistics from the calculator. So I'm going to go over to stat calculate one variable statistics. List 1. I need the sample mean and sample standard deviation. So for the Chips Ahoy group, I have a mean of 18.4 and sample standard deviation of 1.78. And then I'm going to run the same thing for list 2. For the great value group, 19.4 and 3.6. 19.4, oops, 3.6. Okay, you'll notice I'm using subscripts. I'm labeling. If you're not going to use the subscripts or any symbols, just make sure you have like CA and GB so your AP reader knows what these summary statistics go to. Okay, moving right along. So I am going to take a look at calculating a t-distribution with 9 degrees of freedom. My test statistic is going to be the statistic, which is going to be the difference in the sample means. Oh, this is embarrassing. I'm doing a test and it says to do an interval. So let's take a back step here. This is a 2-sample t interval that we are doing, 2-sample t interval. I don't need that. I will need all of this information. So this is going to be 18.4 minus 19.4. That's the way I set up my subtraction. Plus or minus, I'm going to need a critical t value here with 9 degrees of freedom. So you'll remember, you go to inverse t. If I have 95% confidence, that means I have 2.5% in each tail, 9 degrees of freedom. And my critical t is 2.262. And at that point, now I have the standard error, which is adding the variances. So the variance of the Chips Ahoy divided by the sample size plus the variance of the great value times or divided by the sample size. At this point, I'm going to plug this whole thing into my calculator. 18.4 minus 19.4 minus 2.262 times the square root. And if you use the alpha y equals, you can get a fraction. It'll make typing this next part into the calculator much easier. So I can see my lower bound's about negative 3.87. And if I just hit second enter to copy and paste that, or you might have a fancier calculator that has a different way, and just change it to the upper bound. So I'm looking at a confidence interval of about negative 3.87 to positive 1.87. At this point, I should know, like, hey, this interval captures 0. 0 means there's no difference, so it doesn't look like we have convincing evidence that there would be a difference. All right, that's it for the do step. Conclude. Nothing new here. This is going to be the same thing that we've done in the past. We are 95% confident that the int interval from negative 3.87 to 1.87 chocolate chips captures the, and now I'm just going to use the context here, the difference in the mean numbers, or the true difference in the mean numbers of chocolate chips. So captures the true difference in mean number of chocolate chips in Chips Ahoy and Great Value cookies. Okay. Oh, that's fantastic. Sorry, I was covering that up. So it doesn't ask this, but if they said, is there evidence of a difference? No, we don't have evidence of a difference because 0 is included in this interval, negative 3.87 to positive 1.87. So that's how you do a 2-sample t interval. In the next video, I'll move on to the 2-sample t-test. I hope this was informative and it made sense.